The Large UV Optical IR Surveyor, LUVOIR, is a concept for a multi-wavelength space observatory with lofty scientific ambitions. This mission would enable significant advances in a wide spectrum of research, from reionization to galaxy creation and development, star and planet formation, and solar system remote sensing. LUVOIR's main purpose is to characterize a wide spectrum of exoplanets, including those that might be livable, or possibly inhabited. NASA is planning 4 space telescope missions for the 2030s. LUVOIR, the Habitable Exoplanet Observatory, HabEx, the Origin Space Telescope, OST, or Far-Infrared Surveyor, and the Lynx X-ray Observatory. The destiny of these 4 mission proposals is in the hands of the National Academy of Sciences Astronomy and Astrophysics Decadal Survey, which identifies the field's objectives for the next decade. In terms of what LUVOIR will provide us, it's difficult to overestimate the importance of such an observatory. Sure, its technical specs are excellent, but what truly stands out is how it will contribute in answering some of the most pressing issues concerning the universe today. Are there any habitable planets in the nearby? We're not seeking for possibly habitable worlds, or worlds with biohints or biosignatures, or worlds that may eventually be home to humanity. We're talking about the big one, determining if the closest Earth-like planets have life on them. And we're not talking about 1 or 2 close planets here, but dozens, if not hundreds. With LUVOIR, we will not only be able to directly picture these worlds, but we will also be able to determine what fraction of them is covered by continents versus oceans, what the properties and coverage of clouds on those planets are, whether their land mass is green and brown and ice over with the changing seasons, what their atmospheres are made of, whether there's any evidence of oxygen, nitrogen, methane, carbon dioxide, or even complex molecules, and what it all means for the existence of life on those worlds. It may investigate hundreds of Earth-like planets and test their atmospheres, LUVOIR scientist Jason Tomlinson stated. Finding an exoplanet with evidence of life would be a finding on par with Newton, Einstein, Darwin, quantum physics, Hubble's expansion, and so on. LUVOIR is the first telescope built from the ground up with this revolutionary aim in mind. LUVOIR will have the capacity to expose nearly all of the objects that Hubble, Webb, and Roman will miss. With its size, optical capabilities, and unique instruments, LUVOIR will break all prior records for what it can uncover. The transition from Hubble, which is near the ultimate limit of the weakest objects in the extreme deep field, to LUVOIR will disclose things 40 times fainter than what we can now view. That's the same as going from enormous ground-based telescopes to Hubble, or from a 30-second exposure with a 2-meter telescope to an all-night exposure with the world's greatest telescopes. This will disclose more tiny, faint galaxies at longer distances and in larger numbers than any other telescope has ever done. It will find more tiny, dim, and distant objects in our solar system than any other telescope ever built combined. It will capture photographs of the outer planets that are as excellent as the ones taken by Voyager 1 and 2 when they physically traveled there. And it can do so whenever we choose. It will detect, measure, and classify individual stars that are fainter and further away than ever before, including an unprecedented number in galaxies more than 1 billion light-years away. Essentially, if you're looking for items that are faint, far away, tiny, or otherwise difficult to define, LUVOIR will not only locate them if you know where to look, but it will also tell you significantly more about their features than any other tool. It will also be able to view in detail what any galaxy in the universe looks like. Imagine being able to point your telescope at every galaxy in the universe, an object normally 100,000 light-years large, and seeing details as small as 300 light-years across no matter how far away it is. LUVOIR would depict a galaxy the size of the Milky Way, no matter how far away it is from us, as at least 400 pixels wide, with over 120,000 pixels of valuable, bright information in every frame. If the same galaxy was scanned with Hubble in the same period of time, it would contain just 0.06% of the information contained in a LUVOIR image, with far lower resolution and light-gathering capacity. We may discover how each galaxy we measure spins, which parts in each galaxy are actively generating stars, how gas and dust are distributed in each galaxy, and what satellite and dwarf galaxies are doing out to billions of light-years. Plus a lot more. LUVOIR would answer the most pressing concerns about our universe, from objects in our solar system to exoplanets, stars, galaxies, and the greatest cosmic structures of all. All we have to do to realize our aspirations of understanding what exists in the universe is to choose to develop it. But the ultimate aim is that we will not just develop LUVOIR, the greatest of the current alternatives, but a series of observatories that will cover different wavelengths and complement one another. Origins, a far-infrared telescope, is suitable for measuring information about newly formed planets and stars. Lynx, an X-ray telescope, may be able to view details about black holes, neutron stars, and colliding galaxies that no other observatory can. Even HabEx, an exoplanet-optimized mission that is in every way inferior to LUVOIR, could launch on a far shorter timetable, making it an appealing choice.
Encourage us by subscribing to our channel and watching more videos like this.